For this trig integral example, notice that we actually have a definite integral this time, which is different than an indefinite integral. When you have limits of integration like minus pi over 2 to pi over 2, what you're actually looking for is the area under this guy's curve from A to B, basically. So the way we do definite integrals, as you probably know already, is you want to find this guy's indefinite integral like we typically do, find his antiderivative rather, and then we want to evaluate that at B and A and then subtract those two answers. That's called the fundamental theorem of calculus. You probably remember that from Calculus 1. So anyway, the meat of this problem is actually integrating this guy. This is actually the bulk of this problem here. So I have a trig integral that has a cosine cubed in it. Now, one thing I remember about these kind of integrals is that if I can find one of these guys, sine or cosine, that has an odd power, then I'm going to peel off that odd layer and kind of put it towards the end. So we'll write cosine of t dt. We'll kind of save this guy towards the end back here. And then whoever's left, in this case, cosine squared would be left. In fact, it'd be 10 cosine squared of t, integral from minus pi over 2 to pi over 2. What we want to do is we want to convert whoever's left, whoever's remaining, turn him into sines. Now, the reason this is possible is because since you took away the odd layer, what's left is even, right? What's left is even. And if you have an even power of sine or cosine, you can use basic trig identities to convert one of those guys into the other. All right, so let's do that. So we'd have here the integral from minus pi over 2 to pi over 2 of 10 times the quantity 1 minus sine squared t. And then back here at the end, we would have cosine of t dt, right? So I have a function of sine with the derivative of the sine at the end. So we have a function of u with a du at the end. So just to be clear, my choice of u is going to be sine t, and my du is going to be cosine t dt. All right, so let's write those details down. All right, so we'd have, let's copy this on the next page. We have the integral of 10 times the quantity 1 minus u squared with a du at the end. And see where we got that from. We had 1 minus u squared, and then the end makes a du basically. Now, one thing you probably also remember from Calc 1 is that if your limits of integration were negative pi over 2 to pi over 2, there's no reason after we do a u substitution they would stay the same, right? The reason for that is this is what u ranges between, not what t ranges between. And so what we have to do in this type of situation is convert from t's into u's. And luckily for us, there is somebody who converts back and forth between t and u. So let's do that real quickly. If t was negative pi over 2, what would the equivalent u be? Well, I'll just ask you, what's the sine of negative pi over 2? Hopefully you know your unit circle pretty well, and we would know that this answer would be negative 1. It's kind of negative 90 degrees. It's down the y-axis. The y-coordinate's negative 1. That's the sine. And then what's t at pi over 2? Well, that would make u equal sine of pi over 2, which is positive 1. So if negative pi over 2 to pi over 2 was your old limits, then negative 1 to 1 will be your new limits, right? So we'll keep these new limits in here, not negative pi over 2 to pi over 2. All right, so this is a pretty straightforward integral to do. You could either distribute the 10 through, or you could pull it outside the integral. It doesn't really matter. We'll just keep it here. It doesn't matter. So we'll have 10. The integral of 1 would be u. The integral of u squared would be u cubed over 3. All right, because this is a definite integral, we put a bracket with minus 1 to 1, right? Minus 1 to 1. Little algebra left. You might can do this faster than I can. We'll give it a shot. If you plug in a 1, let's just do that math. 1 minus 1/3 makes 2/3. And then 2/3 times 10 makes 20/3. Now let's plug in -1. -1 minus 1/3. Let's see, -1 minus 1/3 would make -4/3. -4/3 times 10 would make -40/3. But then this is a minus a negative, which actually turns that into a plus, actually. And so 20/3 plus 40/3 would make 60/3. And what is 60/3? Well, 60/3 would be 20, right? So 20. So what is 20 again? Well, it's a numerical value. It doesn't have a plus c or anything like that. This was a definite integral, and 20 is the area under this guy's curve from minus pi over 2 to pi over 2. So it's the same as the rest of these inverse trig integrals where you save a du and all that kind of stuff. But just if it's a definite integral, at the end of the problem, you plug in the upper limit, you plug in the lower limit, and you subtract.